Given that the integral from a to 2a of 10 minus 6x with respect to x is equal to 1, find the two possible values of a. So we're going to integrate here. The 10 becomes 10x. The 6x is going to become 3x squared. Our upper limit is 2a, the lower limit is a. We're going to substitute those limits in. So substituting the upper limit first, we've got 10 times 2a minus 3 times 2a squared. Substituting the lower limit in, we've got 10 times a minus 3 times a squared. Now let's just tidy up that a little bit here, because we've got the 10 times the 2a, which is 20a. Then we've got the 2a squared. So 2a times 2a is 4a squared. Multiplied by the 3 will be 12a squared. Now simplifying this, we've got 20a minus 10a, so that's 10a. And then we've got the minus 12a squared minus 3a squared. So that's going to add 3a squared. Minus 12a squared plus 3a squared is minus 9a squared. And this integral with those limits was equal to 1. So I've now got a quadratic equation to solve. So I'm going to add the 9a squared to both sides, and I'm going to subtract the 10a from both sides. I'm then going to factorise. And I find that either a is 1/9 or a is 1. So those are the two possible values of a. Part B says, labelling all of the axes intercepts, we need to draw a sketch of y equals 10 minus 6x between x is 0 and x is 2. So actually I don't need all of this. Right, this is a straight line. It's got a y-intercept of 10. It's got a gradient of minus 6. So it's going to look something like this. Let's get the x-intercept there, so I know that's going to be when y is 0. So if I make 0 equal to 10 minus 6x, so 6x is equal to 10, so x would be 10 over 6, or 5 over 3, so that's 1.6 basically, 1 2/3, which is good because I only want to go up to where x is 2. So if x was 2 here then, and x is 0 there, then yeah, I have drawn the graph of y equals 10 minus 6x between 0 and 2. Part C of the question. With reference to the integral in part A and the sketch in part B, explain why the larger value in part of A, found in part A, produces a solution for which the actual area under the graph between A and 2A is not equal to 1. State whether the area is greater than 1 or smaller than 1. Right, let me just reread that question again, and I'm going to underline some key parts. So with reference to the integral in part A and the sketch in part B, explain why the larger value of A so that's the A is 1, that's the larger one, produces a solution in which the actual area under the graph between A and 2A, okay, so if A is 1, then we're talking about between 2 and 1, between 1 and 2, is not equal to 1. States whether the area is greater than 1 or smaller than 1. Okay, so like I say, if A is 1, then we're looking for the area under the graph between 1 and 2. So that would be this area here. Let me highlight that. Now notice here that this area is underneath the x-axis. So that would be producing a negative area, which would then take away from the positive area here before it was made equal to 1. And so that's why the actual area, the green area I've shaded there, is bigger than 1. It's just when I did the calculus, when I did the integration, we've included the negative and so subtracted it. So, to explain this, I'm going to say that when A is 1, the integral limits of 1 and 2 include part of the graph that is below the x-axis. So producing a negative area. Therefore, the total area will not equal 1, it will be bigger than that. And there we go, we have answered that question.